Good afternoon, everyone. I'd like to thank you for coming out during our lunch hour here. So I'd like to quickly introduce you to ourselves and to Thalmic Labs. So my name is Gord Tanner. I'm one of the software developers at Thalmic. And this is Scott Greenberg. He is a developer relations. And before I get into exactly what we're going to talk about, I'm going to start with a quote. So this quote is from Arthur C. Clarke. When a distinguished but elderly scientist states that something is possible, he is almost certainly right. When he states that something is impossible, he is also probably wrong. Now, to tell you where we're from a small town in Canada called Waterloo. Waterloo is a university town. It has 2 universities and 1 college. One of the universities is rather well known, the University of Waterloo, for its computer science and engineering. Recently, by Startup Genome, there was a report of the top 20 cities in the world for startup ecosystems. This list contains cities such as Silicon Valley, such as New York, Paris, Sydney, Moscow. And on this list of those 20 was the city Waterloo. Waterloo has a population of about 300,000 people. And it was the only city in this list that had to specify the country. Now, we're a small town, but you may have heard of BlackBerry, one of the phone companies that came out of this town. But what is starting to be made apparent to the rest of the world is the thriving ecosystem of smaller companies that are starting up in this little research bed. There's a company called Communitech that fosters growth amongst all these startups, and there's about 500 startups started almost every year in this small little research town.
So to give you a bit more background on, to give you a bit more background on Thalmic Labs, the founders of our company, Steve and Matthew and Aaron, all went to the University of Waterloo. They actually all graduated from the same program. It's called Mechatronics Engineering. It's a blend of software, mechanical, and electrical engineering, kind of perfect for creating a hardware device that has a lot of software components to it as well. So all these guys graduated from the University of Waterloo, but during school, 2 of them went to Switzerland, actually for a study term, to ETH Zurich. And while there, they actually saw a man very similar to this one, walking across the street and using this device. So this man is visually impaired. And so he can't normally walk around. It's harder for him to navigate a city. You can imagine busy city streets, going around Devox, bumping into people. It'd be very difficult. So he has this wand here that he's able to use to actually get around. And what's actually happening is there's a camera in the wand that will detect things in front of him and vibrate or give him tactile feedback on his hand, so he can understand what's in front of him and he can navigate around it. And so the founders saw this and they thought, we can make something better. So these are ambitious people, naturally, but we can do something better than this. We can give people more information. And so the thing I'm wearing over there is not a diaper, I promise. This is something that came up in a few months' time. It was for a research project. What it is it's a belt, similarly to the way that wand works. The belt vibrates according to where things are in your area. So now you don't have to move the wand around. You can walk around and naturally it will vibrate around your waist. The thing on my head is actually a camera, and that will actually tell you who is in the room with you, read signs to you, do things like that. So this was kind of a natural starting point for where the founders got interested in wearable computing. And so this is an interface that enhances our abilities, or in this case, enhances the abilities of someone who's visually impaired. But it's something that helps us gain extra senses, make us into something with extra powers, if you will. And so that's where the founders kind of realized that this is something that doesn't have to be just for the visually impaired, can be for everyone, and can really go forward in that way.
Now, in wearable computing, there's a lot of effort happening currently for what we like to call the output of wearable computing. So devices such as Google Glass, such as our smartphones, such as smart watches are all focused on providing information to the user. It's a really interesting problem. Some amazing devices are starting to be developed to solve this output problem. Now, what was compelling, though, there's the other half of wearable computing that the founders and us thought wasn't being addressed right. It was the problem of input. The input to wearable computing is one of those problems that we felt wasn't quite being solved. And we wanted to be able to connect our physical world to our digital world. Now, when we, as humans, we evolved using our hands, then using tools as natural extensions of our hands. But we've been using our hands for as long as we've been walking upright. Now, a lot of the existing gesture recognition technologies are camera-based. So they'll involve the user standing or motioning in front of a camera to detect the signal processing of the image, and will detect where the user's hands are, where the user's fingers are, and so on and so forth. These systems are great and provide a very high fidelity motion capture, but they're slightly awkward when you're thinking of mobile situations or when you're on the go, or when it is not convenient to be standing in front of a camera. So during the founders' research with wearable computing, they learned a lot about electromyography, or EMG, which is a technique for evaluating and recording the electrical activity processed by the skeletal muscles. Now, muscle tissue, when at rest, is electrically inactive. But when you contract your muscle voluntarily, action potentials will begin to appear, which are the short-lasting event in which the electrical membrane of the cells changes rapidly and rises and falls. Now, when the muscle is fully contracted, there will appear more action potentials. So it's possible to measure the strength and what muscles are being actuated when making hand gestures. Now, in combining that with sensors that would measure the electrical impulses, along with accelerometer for 9-axis of motion, we're able to detect what the user is doing with their hand in specific poses, as well as the motion of those poses. So, with going with this idea, they presented it to some people, and everyone told them this was impossible, this won't work. And in youthful naivety, they decided to give it a try. And the first Myo was built. It consisted of a bunch of wires basically glued to an arm, just to measure to see what would happen if we were to take the muscle movements, measure them, and try to use machine learning to detect if the user was making a fist, was touching the 2 fingers, touching 4 fingers. And the initial results were very promising. And it was better than they had hoped. Taking that prototype in hand, they went to another program in Waterloo called Velocity. It's run out of the University of Waterloo, and it is an incubator for startups. So rather than the students traditionally staying in a dormitory, they would stay in an accelerator program dedicated for startups. So they would live, work, and form companies during their school term. Certain companies in the Velocity Startup Program are granted $25,000 to start, and they're given office space. There's a beautiful old tannery factory in the center of Kitchener-Waterloo called the Tannery. And in there is the Velocity Garage. It's an old shipping bay that has been converted to co-working spaces. And that's where Thalmic was formed. That's where the initial work was done after entering Velocity. And from there, the team grew. Starting from the 3 initial founders, we grew hiring experts in machine intelligence, experts in electrical engineering, manufacturing. Our team is currently 40 people. We are working very hard to build this, what we feel is the next evolution in wearable computing. Now, getting noticed in Waterloo is very easy, being a small town. But during this, we applied to Y Combinator, which is a larger startup incubator, where they basically give you the guidance and the exposure to the investors on Silicon Valley. So the founders went there 3 months, intense, working to iron out our brand, to iron out how to sell, how to market. And I'd like to just show you a quick video on our first marketing video to give you an idea of what we're aiming for with the Myo. So we released that video and opened up our pre-order system. Rather than going through something like Kickstarter or the existing crowdfunding, we decided to run our own crowdfunding. And rather than gathering money up front, we decided we would open it up and we'll get a pre-order when we ship it. That's when we'll bill our users. So not knowing really what the market was, not knowing what people would react to this, they apparently really liked it. In 28 days, we sold 25,000 units, which was just shy of $4 million. It was a little exciting, a little kind of crazy, and it really solidified that people want this. People are starting to realize that they can act in the physical world and interact with the digital. And this is the next evolution in computing. So a little information about what exactly is built into a Myo. It's a Bluetooth low energy interface, Bluetooth 4.0. Inside is a 9-axis inertial tracking system. So compass, accelerometer, gyroscope with sensor fusion. In it is haptic feedback, so we can vibrate at different pulses to notify the user of turning on, disconnecting, switching devices. And it also has the non-contact muscle activity sensors. So similar to the touch screen on your cell phones where they're non-capacitive. Earlier EMG detection sensors required you to cover yourself in almost like a gooey paste to get connectivity, where that probably wouldn't be a popular option. So using the technology similar to touchscreens, we're able to just use contact with the skin is enough for us to measure the impulses. Now, there's a lot of really, really awesome integrations we can see with this device. The hardware side is probably the more visually exciting. So we've been playing around. Our office is full of toys. So we'll have quadrocopters all around in various states of disrepair as we run them into ceilings and walls. There was another team here that had a mini quadrocopter. I don't know if you managed to see their presentation. They gave us one to play with. So last night I was in the hotel room just seeing if I could get it to work for this presentation. It was written in Python, which is a language I've never coded before, and which is not an interface that we currently supported. So I ported our API to Python last night, and I was playing around with this API, and I gave up around 1 o'clock when I launched the quadrocopter, and it hit my girlfriend in the head while she was sleeping. So I decided probably not. Next time we'll show that demo. It'll definitely make coming across to Europe a lot easier for the presentations. Shipping a quadrocopter or getting through airport security is quite challenging. Also, integrations with Sphero balls we've done, the Oculus Rift, or even just simple interactions with your television or stereo, your card, and also using it as an input to Google Glass, because standing in the tram and saying, "Okay, Glass, take a picture," is a little awkward. Now, on the other half of integrations, software is a really interesting aspect. So gaming is a huge industry, and companies have been coming to us just wanting to understand how to use this device, how to interact with it through mobile gaming, through even just sitting on your couch gaming, and also design and media interaction. These are huge markets that are just interested in interacting with their content in a more tactile way. Also, as we're developing this device, we're keeping our eyes that it's a brilliant input device for gesture recognition. But what we're developing is opening up the sensors for research, for health sciences. Because we're building a device that is this cheap and this accessible, we want to open up the data and open our software up to allow health sciences and research to, for example, prosthetic limbs or logging of sports data or strength training. Just there's a wealth of information that our bodies are able to generate that we're not harnessing, and the applications of that are kind of staggering. So I've been talking for a little over 15 minutes, and I haven't shown you any code. And this is developer conference, so I'm going to just go over our API, keeping in mind that everything you see is probably going to change. We haven't started our public alpha release, so this is actually probably the first time anyone's really seen what our API is going to look like. So coming out of the box, we're supporting C++, .Net, which is just bindings to C++, Objective-C for iOS. I've written bindings to Node.js, and plus many more. We started our core in C++ for cross-platform, and you can bind anything to that. So in the future, it's going to be fairly easy for us to write to Java when we go to Android, to Python, which I kind of did last night. So, but for the example right now, I'm just going to walk at a high level over the C++ SDK. It's an interesting challenge as an SDK designer, as an API designer, to think of how to interact with your data, how to, as an input device, how developers will need to write their programs. So as I've been thinking about how these APIs should be structured, I've been borrowing from inputs that we currently have, but thinking about what we would need in the future. So to keep things simple, we're trying to bundle everything into what we're calling a hub. It's just an object that's going to be standard on every platform in some ways. And this is our entry point into the events and the system of the Myos connected. So I said the key word there, event. So every Myo is going to start as an evented system. So we have what are called listeners. And before I joined Thalmic, I've been a web developer for a long time. And something I really liked about the web was the AddEventListener, RemoveEventListener interface, touch start on touch end, but that really free-flowing event system that was available to us in the web, where touch events, which were something that didn't exist when the event system first was created, just fit in naturally. So we're using that similar process in all our SDKs now. So there's hub.AddEventListener or AddListener, hub.RemoveListener. Now, in C, it's a little awkward to just pass in functions. So we have the ability to do that, but what we've done is create a listener that you implement the handlers directly on it. And you can add this listener to the hub for all Myos, or if you pass in a Myo instance, you can listen to the events of a specific Myo. Coming out of the box, we're hoping to support 2 Myos, so a user can have one on their left and their right arm, as well as potentially more for multiplayer gaming on one device. So I said the listener in C++ is a class that you inherit from. And basically for every event type that we have that comes from the Myo, you override the handler function. So they're all structured pretty much the same, on blank, where you pass in the arguments of the event, and all that awesome stuff that you guys are really good at writing will go in between those squiggly things. So our first release of the SDK, we're going to support some these events. We're trying to abstract out a lot of the awkwardness of interacting with this device and make it just simple. We want it to be as easy as when you first wrote your first web page and you added a click event to a button, and it just worked. That's what we want this device to be. That's how easy we want it to be to interact with it. So we've taken out a lot of the events kind of related to the handshake, to the syncing. They're handled over in another object that is going to be publicly accessible, but we're going to run in your app tray a little manager for connecting and discovering Myos and programming them. So basically, we have an add and a remove event, which you can trigger when your listener instance is added to a hub. On remove, you can figure out if someone removed that listener or you're being removed because the hub is being destroyed. On connect and disconnect gives you a signal into when Myos are becoming available to the system and disconnecting from it. On motion is when anything happens in the physical space of the Myo. Now, poses and gestures are terms we've been throwing around, trying to understand good terminology for how to describe what's happening. So when we say pose, think of making a fist. Your hand is in a pose, such as touching two fingers, such as throwing up the horns. All those are hand poses. And then gestures are more dynamic, so pinch zoom. So that's when we can, all our gestures coming out on the first are motion based, but starting with a gesture such as snapping, making a circle, and stopping, that would be a gesture. So motion is a pretty simple object. It has a timestamp on it, has the current acceleration, has the acceleration without gravity. We added that in because we were coding a sample app, and we couldn't figure out why when I held my hand like this, it would keep moving down. And then someone reminded us that gravity. So we'll factor that out for you. It's just a lot easier that way. The velocity and the orientation of device. And because we realize that, like, some people want to make their own gestures rather than relying on the pre-built ones we have, we'll expose the current hand pose so you can monitor the motion and you can detect when someone's moving in a certain direction and starts to make a fist or extends their hand out. So a quick example for this, which I was trying not to kill my girlfriend last night, was, for example, flying a chopper, just passing in the current orientation on this event handler. So you're given the object motion, grab the orientation, and you have your X, Y, and Z, or pitch yaw and roll. Now, poses, like I said, are the static kind of positions of your hand. So whether you're trying to be Spider-Man or like charging a fireball. So a pose has, in this case, a start time and a finish time. We have two events, pose start and pose finish, kind of borrowing from the concept of touch events in the web. We have a type of the pose, so like, for example, fist. I think we have in, out. We'll ship with a predefined set of poses. We're playing around with how to do this with like training lists. The idea is that you should be able to put on a Myo, do potentially a reference gesture, and it will detect what hand it is, what orientation the sensors are, and just know, no matter who it is that put it on. And the current state of the gesture, whether it is holding, released, started. So a quick example of this is my favorite. I used to play a lot of Street Fighter when I was younger, and as soon as I got the Myo, I wanted to be able to shoot fireballs out of my hand. So on pose start, you get the pose instance, and if the type is a fist, I'm going to start charging the fireball. And on pose end, whoops, that's a typo. I'll throw the fireball when it ends. So lastly is the gesture. The gestures are a little more complicated, a little more dynamic. The gesture has just a timestamp, a type, and a state. And the current types that we support are making a clockwise circle, counterclockwise circle, swiping up, down, left, right. Then the state is basically none, start, recording, and end. As we're developing this API, we're trying to make it both event-driven, which is really easy to work with, as well as polling-based. So you should be able to get an instance of the Myo and poll its state, which leads to some awkward objects determining if there's currently a gesture being performed, which doesn't really look nice in an event API, but you need in a polling API. And so with that, my example here is we actually coded this up for an appearance on the Today Show, was interacting with Google Earth, which we use the gestures to move left, right, up, or down, and we would pan the map based on the direction that the gesture was being performed. And then zoom it in with a counterclockwise circle or zoom out with a clockwise circle. So this is where it gets interesting. This is where I take, hopefully, the device and get working. I thought it would be a little more interesting to show another one of our languages rather than C, C++, and live coding is always interesting. As I try to even get my screen on. There we go. Live programming is an interesting thing in talks. Everything that will go wrong does. And I didn't want to have to try to make up more jokes than I know during compiles. So I'm going to use Nodejs. So it's a JavaScript sample. So I'm just going to start up Node here. Okay. So the Node, every SDK that we write, every language that we support, we don't want to be looking like a C API in JavaScript or looking like a JavaScript API in C. We want to take what the language is naturally good at and adapt our API to fit. So this API is slightly different than the C++ API, but it just takes in some of the flavor of JavaScript and Node and makes it, but still behaves those concepts that we're trying to get across to the user per the platform. So let me just reset this guy here. Okay, so I'm just going to grab the admin. This is that. So admin is an object that allows us to interact and connect to the Myos, find the Myos in the range. So I'm just going to go admin.onDiscovered. So I should be able to go admin.startDiscovery, and it's going to discover any Myos that it finds in range. So we have a few in our bag. Don't mug us. So that just lists all the Myos that are currently around. I can and then in here, that's where we have the ability to connect to a Myo. So sorry, this goes into sleep mode right now, and I broke the button on it. So I'm holding the button to hopefully wake it back up. There we go. So I should be able to do connect. You won't ever have to do this. So I don't know if you can see that. There's a little light on the Myo there that's now blue. That indicates it's being connected. So that's good. Step one. So there's a couple other API methods on here, such as set data mode, training and loading different classifiers on it. that's all abstracted out. That's for our engineering teams to experiment with our machine learning algorithms. But the key is that just in this object right now, I can connect to a Myo, which is pretty cool. Now the hub is the object that I was talking about before. This is where you're going to be able to interact with your Myos to set your event. So I'm going to go hub.onMotion. And I'm going to probably cause seizures. But this is all the data we're getting from the Myo. As I move it around, we're getting the acceleration, acceleration with gravity, the velocity, orientation, and the pose type that I'm currently doing. So I'll stop that and go again. Require. Now, another event we have, I'm just going to show the raw data. So this is just the raw and electrical values of my muscles right now. So these are the 8 sensors built around the Myo, the raw values that we're getting. So you can see as I actuate different muscle groupings, we're able to take this data and through our machine learning algorithms detect what the user is actually doing with their hand. We'll probably be exposing this API to specific partners, to health sciences, to universities. Unless you have a lot of PhDs or a lot of time on your hands, it's kind of hard data to work with, and you need to know a lot about the human body and how muscles work. But it's kind of cool to watch it. I know I'm a developer. I'm a developer at heart, and I kind of just love watching the graph of this go, just because it's real, it's tactile, you're feeling what you're doing, and you're watching it on the screen, which is always a really cool experience. So everything worked, which is good. Also. Here, I'm just going to run it. I made a much better example. So I made a command line just to make it easier. So one of the other, here I can hold up to my mic. Now, I think, here, let me see something.
Not a speaker, we swear.
Yeah. Sorry, let me see something. Example CMD. Did I support that? Okay, hub command 1. I think maybe, or not. No, I thought I did that feature, but I guess I did not. We support different durations of vibration. Actually, I'll add it right now. Whatever, right? I think if I pass a 1, it will vibrate a little longer, or it will crash. It's a little longer. Let's see what happens if I pass 2. I can see our I'm sure the development team is going to hate me. They're going to be like, what are you doing? That sounded a little okay. Let's pass on 3. One of these times it's going to. Oh, I need to stop it again. That sounds the same. Anyways, I probably should have did that before I got on stage, but you get the idea. So, want to show the
Yeah.
iOS stuff? We have some time.
Sure. Here.
So this is where it gets interesting. Here. Okay, let's disconnect from him. So it's yours. So, wait, we'll hold that up.
Probably go closer to the camera if you want.
All right, so this is just the same data, put a little nicer. I got an email. So that's just the motion, pitch, yaw, roll. This is the nice visual display of nothing apparently. There we go. Oh. So you can
there's actually 8 plots here. We can scroll it down as well.
Yeah, really
but
hard. There we are.
This just corresponds to the 8 numbers that Gord had up before when he was going through the raw data.
Yes. And we had a really awesome demo on here where we have a music player which we can control flicking our wrist back and forth. And we loaded it on here, and we didn't load any music. So navigating your albums when you have 0 is not an exciting demo. And I don't know about you guys, but it's been really hard to connect to the internet while we've been here. So I'm just going to switch back to here.
Great. So that was pretty cool stuff. And I hope Gord got through a little bit of what we're really planning here. Having APIs for everything we can, and actually we're planning on open sourcing them as well. So hopefully having everybody make whatever platforms they want, or make APIs for whatever platform they want. It's really going to be impressive. And I think what is really going to make it go that much further is the power of the developers that take this and expand on it and go further. And even though, we had the disclaimer, everything will change. Gord mentioned that, this is probably the first time anyone has seen a lot of those details in there. We are planning an early access beta program specifically for developers, and we will be shipping out units starting next month for that program. So while this stuff is today, and next month things can change, next month we are also shipping things out. So there is an opportunity there for everybody here potentially to get into that program. You could apply on our website. It's actually developer.thalmic.com. We've also got a number of other resources up there now. It's a little bit sparse. Further to the everything will change kind of mantra. We've got forums up there. You can join the community, check out developer news, and go from there. So this is a program that we're using to help encourage everybody here and developers across the world to create amazing things with Myo. And we're expecting that, further to the ideas we had in the video that were pretty cool, we expect that a lot of you here are going to think of ideas that are going to be just as great and probably even more great. And so that's where we see the value coming in. And so developers are not a side part of the strategy, they're the whole strategy. And having the APIs Gord is talking about and having these things available for you and for everyone else is a core part of what we're doing. And so that's something we're really trying to push moving forward. And if you keep track of us in the future, we're definitely going to be looking to keep doing that. So check out the website, developer.thalmic.com. Come down and talk to us. I think I have some t-shirts to give away, stuff like that. Feel free to just come down and chat. We'd love to answer any questions about the API, about everything else as well.
So lastly, just we figured we had an hour to talk. Thought we'd leave it open to just meeting people. And we saw we were during lunch, and we figured by now everyone's probably pretty hungry. So we're going to end our session just a little early. We're going to open it up for questions. You're welcome to stay and ask us questions. But thanks for coming, and happy hacking.